Okay guys, here I'm going to just show you guys how you would graph a rational function, and then we can answer a bunch of limit questions that I have about the same rational function. So the four things you always want to look for when you're graphing a rational function: you need to find the x-intercept, the y-intercept, or intercepts. Well, it's only one y-intercept, and the vertical asymptotes and the horizontal asymptotes. So we're going to find that first. X-intercept, you put 0 in for y. So you want to know where this fraction equals 0. Well, fraction is going to equal 0 when the top is 0. So you can see, actually I forgot, we should factor completely first. And this is x minus 2, x plus 2. The rest on the top looks like it's good to go, all factored. And then the bottom is done, all factored out already. Okay, now there's one more piece here that we can look for: horizontal asymptotes or holes. Sometimes there's holes in a graph. I noticed there was one here, so I got to put that in there. Sometimes there's not. Okay, so when is this top 0? Well, it's 0 at 2. So 2, 0 is on my graph. 2, 0 is on my graph. And now -2, I can see there's a hole here. So you can see that this right here is, you can see that there's x plus 2, and x plus 2 is a factor on the top and the bottom, so there's going to be a hole there. So I'm going to go right down here and put in that there's a hole at -2 something, and I'll show you how to find that, where that hole is in a minute. I can see that there's an x-intercept at -3, so we have -3, 0, and at 1/2. Those are all the values that make the numerator 0. On the y-intercept is when the when you put 0 in for x, and I can see here it's going to be 0 on the bottom, so I can't divide by 0, so there's none. There are no y-intercepts. Vertical asymptotes are, we get with the numerator, and x can't be 0, so x equals 0 is going to be a vertical asymptote. X equals -2, no, excuse me, oop, I blew that. That's where there's going to be a hole, so I'm not going to do that one. X equals 3, and x equals -1. Those are the vertical asymptote. Now for horizontal asymptotes, you count the degree of the top. So I can see the degree of the top here. That's going to be degree 2. If I multiply by another 2, that's 4. 5. So the degree of the top is 5. And the degree of the bottom is 1, 2, 3, 4, 5 as well. So that means there's going to be a horizontal asymptote at the leading coefficient of the numerator or the denominator. I can see that if I multiply the top out there, I'm going to get 2x to the 5th. And on the bottom, I'm going to get just plain old x to the 5th. So y equals 2 is going to be a horizontal asymptote. Okay, so now I'm ready to graph this thing. Let's do it. Use purple. Okay, so I'm going to make an x and a y-axis. I'm going to put the graph is purple, but I'll make it graph in black. So now the points that I need are 2, 0. So we'll just put there's a point that's on my graph. We're going to have 3, -3, 0. So 1, 2, 3. There's a point on my graph. So 2 and -3. And then 1/2. So that's like in here. So there's 1/2, 0. I'll put a little note just to arrow. That's where that is right there. That's 1/2, 0. Okay, just erase it so you can see. And then we have the vertical asymptotes are at x equals 0. X equals 0. X equals 3. And x equals -1. Okay. Y equals 2 is a horizontal asymptote. So I'm going to put that in there. There it is. Look, I've got it all labeled there too. Y equals 2. And there's a hole at -2, but I'm going to deal with that later. Now I just need to start this graph. I always want to start left to right. So I'm going to find f of -100-ish. And all I really care about is if it's positive or negative. So let's clean up. We need to clean up a little bit here. So I'm going to pause. Alright, so f of, whoops. Okay, so we find f of, I'm going to do it over here where there's more space. So f of -100-ish, all we really care about is if it's negative or positive. So I just put it in, I'm going to use the top one here. If I put -100 in there, that first thing will be positive. And then times a positive. That's going to be a negative. So we got, I'm using this one right here. And then on the bottom it's going to be negative times a negative times a positive times a negative. So what do we got? 3 negatives, 3 positives. So it's going to be positive. Or 4, right? Yeah. So it's going to be positive. So now I know this graph starts up here somewhere, and it's going to, doesn't explode, it goes right towards the asymptote. So I'm going to go this way. Probably goes up a little bit, and then I can see that I got to go down. And at this -3, I can see that that root is squared. So I need to bounce off that, and then I'm going to go back up towards the asymptote there. Then at this one, which is x equals -1, there's a degree 1 here, so it's going to be a flip-flop. So I'm going to start down here, and then I just got to turn right back around again because there's no way to cross that, and there's another asymptote. At x equals 0, it's a flip-flop again, so I'm going to go through that. At half, this is degree 1, I'm going to go straight through that. At 2, I'm going to, again, this is degree 1, so I'm going to go straight through that. And then be close to the asymptote. At this asymptote, it's x equals 3. At that one, it's squared, so this is a flip-flop, so it's going to be straight back like that, and then get closer to the asymptote again. And there's my beautiful graph of this function. Now I can answer all these questions. What's the limit as x approaches 0 from the left? That's going to be -infinity. We'll make them in red here. So this one's going to be -infinity. 0 from the right is +infinity. You can pause this, answer these questions, and then, you know what, I'm going to fill them all in, then you can look at them later. One more thing is you have to find out where this hole is. So what you need to do is put in the value. There's definitely a hole at -2. And to find what it is, you find f of -2, you put it in to the function everywhere except where you can, which is at -2. So I'm going to go, I got to look back here. So I'm going to put it, f of -2, back into this thing. I can put it into this first thing, and it would be -4 times, can't put it into the next one because that gives 0, but I can put it in here. -2 plus 3 squared is going to be just 1. -2 in there would be -4 minus 1 is -5. All over. And I put it in here, I get -2. And then I can't put it in the next one. I can put it in the next one. -2 minus 3 is 5 squared is 25. And then down there, -2 plus 1 is -1. So when I multiply all those, I get, let's see, this is now positive. This is positive. 5 into 25 is 5. 2 into that is 2. So it looks like we're going to get 2/5. Which looks good because I can see here that at -2, that point on that graph is going to be -2, 2/5. And that's where the hole is. Except I should make it look like a hole, which I haven't done here. Let's make it look like a hole because it's really a hole. So we're going to fix this drawing and put a hole in our graph. Can you kind of, there we go. That's pretty good. Okay, so I've answered some more of these questions. You can see I got negative infinity, infinity doesn't exist. As x approaches negative 2 from the right, left, and the functions, it's 2/5. F of negative 2 doesn't exist, though. And f of negative of 3 from the left is positive infinity. And 3 from the right is positive infinity, so it's going to be in positive infinity there. F of 3 does not exist. Okay, 1 from the left is, let's see, 1 from the left is whatever f of 1 is. F of 1 from the left is, if you plug it in, it's just going to be f of 1, because this is continuous there, so it's actually negative a half. So I'm going to find this first, and these limits are all going to be the same because it's going to get closer to that at that point. So these are all negative a half. X goes to infinity. This thing is going to get closer to the horizontal asymptote, which is 2. And negative infinity is 2. And there we are, all set, all done. That's it.